Lesson 5.8. Analyze graphs of polynomial functions. So we're looking at graphs this time. If we have a polynomial function, you know these four things. If k is a 0, or sometimes called root, then you know it's a solution of the equation f of x equals 0, because that's the definition of a 0. A 0 is a solution when the function equals 0. We also know if we graph it, k would be an x-intercept, if it's a real number. If it's an imaginary number, of course, it's not on our graph, because our graph only graphs real numbers. And x minus k is a factor of our function. Use x-intercepts to graph a polynomial function. So here's a function. It's been factored already. We didn't do the factoring. That's the way it came. Since the x plus 2 and the x minus 3 are factors of the polynomial, then the x-intercepts are -2 and +3. So I could put those on my graph. There's the -2, +3. Notice on my graph I am counting by 2's. So to do the rest of the graphing, make a table of values and finish plotting the points around the x-intercepts. So here's my table of values. In this lesson, you're going to have to make large tables, probably, to get all the cool stuff. And plot those points. And draw a smooth curve. Remember from previous lessons, notice the x plus 2 was there twice. So the -2 is actually a 0 twice. When that happens, we have a 0 repeated an even number of times. The graph touches the x-axis there, but does not cross it. So that's why our graph goes up, touches, comes back down. If the 0 is there an odd number of times, like the 3 is only there once, right? It's x minus 3 is there once. It crosses the x-axis right there. There's things called turning points. Those are the local maximums and minimums. It's where the graph turns from going up to going down, or maybe from going down to going up. We call those turning points. And the graph of every polynomial function of degree n can have at most n minus 1 turning points. So if the degree is 4, it can have at most 3 turning points. And if it has all the zeros and they're different from each other, then there will be the highest number of turning points possible. Calculus lets you find the turning points easily. For us today, we're just looking at graphs. So what are the turning points of this graph? Well, we can see right there is a local maximum. So that's -1, 0. And there's a local minimum, 1, -4. Since there are 2 turning points, it could be degree 3. So this could be cubic. And that's it for today. Have a good day.